Hey there, Hampshire chemistry students. Glad to have you here today. In this video, our goal is that we can write the Lewis structure of various different covalent compounds. So, we've been talking about covalent compounds a little bit, and I want to take a look at an example of one of them, like sulfur dioxide, also known as SO2. So, we have already been spending some time talking about these different types of models of electrons. And what you can see here is I've got a sulfur molecule in the middle. I can know that because it has 16 protons and 3 levels of electrons, and 2 oxygen molecules hanging out on the outside. What I want to do is I want to represent how these guys come to form their bonds and connect to each other. And the great thing about these arrows is it lets us see that really easily. So we know that each of these atoms, since this is the 3s and the 3p and the 2s and the 2p rows, we know that they need to have 8 electrons out in their energy orbitals. So what this covalent compound is going to do is it's going to share electrons with the other atoms. So let's take a look and see how this works. Oxygen needs 2 more electrons in order to fill up its level. So it's going to reach out and say hi to our friend sodium over here and say, hey, you've got some extra electrons here. This, if it shares this with the sulfur, it now has the 6 here plus the 7th. So hey, it's only 1 more away. So it's also going to reach out this extra pair. See how it's the single guy is finding its partner? And we can now see that these two are going to be shared. We're going to have 1, 2, 3, 4, 5, 6, 7th for the shared, 8th for the shared. Then the sulfur also is getting a pretty good deal here because it also can share its electrons over to the oxygen as well. And we can see that this oxygen needs a pair. Okay? It's going to reach out, and why don't we just break up? Even though it is breaking up a set here, if it shares, again, 2 sets of electrons, you can see each oxygen now has its full amount of electrons that it needs. And we have represented the bonding of sulfur dioxide. Now the problem is, well, you can see that this is kind of messy. What I want to do is I want to simplify this drawing into what's called a Lewis dot structure. And it ends up being very simple. Instead of having to draw all these rings for our different atoms, what we can do is we can just go ahead and represent them as their symbols. So my big circle here with my 16 protons is just going to become sulfur. And then my 2 rings on the outside are just going to become oxygens. So a little symbol O here. These shared pairs of electrons are the bonds between sulfur and oxygen. What we're going to do is we're going to represent those bonds. Instead of with circled arrows here, I'm going to use each of these guys to a line to represent each of these circled connections. So my first connection to my left molecule, I'm going to draw 1 line. My second connection, I'm going to draw another line. Same thing over here. We're going to represent these 2 connections. We call these in this case, this is a double bond. If I had a single paired thing, we would call that a single bond. So we can see that these shared electrons come into play, but our last thing we want to represent are the electrons that are still shown around the outside of the atoms. At the top, you can see on the sulfur, we have 2 electrons that are left alone on the sulfur. What I'm going to do is instead of drawing arrows, again, to simplify things, I'm going to turn those 2 arrows into 2 dots. These dots are something that we would describe as a lone pair in chemistry. They are atoms that are not shared between any other atoms on this guy, in this compound. So we consider them to be on their own. And I can see that the oxygen is also going to have its own lone pairs. So this pair I'm going to represent here on the oxygen. This pair I'm going to represent here. Then up here on top and on the side. So we have currently now correctly represented all of the atoms in sulfur dioxide and created this Lewis dot diagram. what we're going to do for the rest of today is take a look at some of the other Lewis dot diagram examples on here. So we're going to represent this. We're going to represent all of our different covalent compounds like that. You can see that we have a bunch of different choices. We're going to pick a few at random, and we're going to make sure that we're going to understand how these guys come together. So let's take a look, for example, I don't know, let's do BF3. And we need to understand how this guy is coming together, and we're going to place this guy with my B's and my F's. Now I could go back and do my drawing with my crazy circles again, but to keep it simple, I'm going to start with a B with its 3 valence electrons surrounded by 3 fluorines with its 7 valence electrons, 7 arrows around each one. Now you might be wondering, Mr. Bartlett, how did you know that the center atom here was going to have to be the boron? Well, there's a very simple rule when it comes to deciding who's your center atom. And that is the atom at the center must have the lowest electronegativity. So it is the atom that's going to want to be, that is okay enough to share out its electrons. As a reminder, electronegativity increases as you go to the right and up on the periodic table. So since boron's about here on the periodic table and fluorine is over here, I know that boron, will have the lower electronegativity of the two. So it is going to exist in the center. So I now just need to make sure that I'm going to start sharing out my electrons according to the valence that they have available. So fluorine has 7 around it. It's going to try to get that 8th valence electron by sharing out to the boron. The boron is going to share out to the fluorine here on the side and over here. The boron has no more electrons to share, so it's going to be happy the way it is. And each fluorine now has all of its guys paired up. Here's the pair here, 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 here for this fluorine. This pairing has this guy and these guys. So all I want to do now is just transfer this into our overall diagram onto our sheet. I made a little spot there, so why don't we call this number 2. So if I have BF3, I'm going to want to represent this setup in my Lewis dot diagram. I'm going to put my B in the center, my F's around the side. Each connection is going to be represented with the line, right? Here's this one going down and going to the side. And then every single lone pair here is going to get represented. So each fluorine is going to have 3 pairs of electrons. Notice how, again, we're keeping them in their bonded pairs. And we're done. Okay? We have successfully represented all of boron's electrons bonding to the fluorines to form our boron trifluoride here. So your job is to do any 15 of your choice on these guys. I would recommend, if you're interested and you want a little bit of a challenge, you could try these guys. These ones are a little bit trickier. They may not have some center atoms for you to branch off of. So you have a little bit more interesting challenge with those. So the rest of this time is yours. Let's take advantage of it and make sure that we're able to meet our goal today of writing our Lewis structure. I can write the Lewis structures of covalent compounds, just like these guys. So have a great rest of your day, guys, and I'll see you soon.